Welcome. This video talks about projection planes for CMMs. So for starters, we have a block here, and I have drawn three different two-dimensional lines on the front surface of this block. We're going to look at a couple different views and look at this through the eyes of a CMM. So there are the three lines we'll be looking at first. I will start from the top view, and we are now looking at line 1. So from the top view, we just see a line that lies along the x-axis. We can see its y position, but we can't see its z depth. If we look at that same line from the front view, we do see the length of the line in the x-axis. We can see its position in z, but we cannot see its y depth from this view. And then looking from the right side, now we just see a point. So we are looking directly down the line. So the right side view really does not provide any usable information for this line number 1 that we've drawn. So we'll go back to an isometric view. We'll turn on line number 2, and this is a diagonal line. This is the bottom edge of the triangle. We'll turn off line number 1 so that it doesn't clutter the screen. And let's again go through and look at the top, front, and right sides. So from the top view, interestingly, line 1 and line 2 look exactly the same. I'll toggle them here so you can see. Now we're looking at line 1. Now we're looking back at line 2. So line 1 and line 2 look identical as viewed from the top view. We'll switch over to the front view, and now we can see, this tells more of the story. Line number 2 is actually drawn at an angle. Looking from the right view, interestingly, we see a line with number 2 from the right view, whereas with line number 1 from the right view, all we saw was a point. Well, that makes sense because this line is drawn on a diagonal, so if you only look at it from the right view, you see its length along the z-axis only. So going back to an isometric view, we will turn on line number 3. We see that that is the vertical component of this triangle. Let's take a look at this from the top view. And interestingly, with line 3, the only thing we see from the top view is a point, which makes sense. We're looking directly down that line. We look from the front view. Now we can see that that is a vertical line. We can see its length. And then looking from the right side view, we can see a vertical line, but probably not as much usable information as we could see from the front. So I guess the key takeaway here is, depending on what you're trying to measure on a CMM, it's very important to tell the CMM how to look at it. So how does this translate into the CMM software? Well, here I've pulled up a dialog for element line. We can see that up here in the upper left of the dialog, and notice that we have these three different projection planes. The CMM software does it a little bit backwards, in my opinion. We have the top plane, which would be called the XY plane. I think this should be the front plane next, but the CMM software calls that the right plane. That would be the YZ plane. And then the third option here is the front plane. That would be the XZ plane. So where am I getting all this information from? Well, if we look in the CMM book at page 34, we have a quick explanation of projection planes and why they're important, but really it doesn't provide all that much value. Here we can see the XY plane is shaded in blue. That's because if you were to dimension this rectangle, you would dimension the length along the X and the width along the Y. Then we have the YZ plane, which again would be called the right plane. That is the Y and Z, because you can measure the length of the rectangle along Y and you can measure its width along Z. And then lastly, we have the ZX plane. In layman's terms, we would call that the front plane, and that is because we can measure the X length, and then the Z would be the width of that rectangle. So projection planes are important for a couple of different reasons. The example cited here on page 34 is talking about measuring a circle, and there's a follow-up video to this video that explains more on that. But I think to start off, it's helpful to just visualize how the software is seeing lines, and then we'll move into circles after. All right, so everything we looked at so far was two-dimensional lines that were drawn on the front plane. We looked at them from the top view, the front view, and the right side view, just to see it tells the CMM software a very different story. So now let's look at a three-dimensional line. So here I've drawn a three-dimensional line that is directly through the center of this block. Now, of course, this is for demonstration purposes only. You wouldn't be able to measure this line on this specific part, but there are other parts with more complex geometry that may require you to measure a line just like this. So this line is three-dimensional because it moves in x and y and z to get from one point to the other endpoint. So let's take a look at how this line looks if it's projected onto the top. Okay, so we see that same line projected up onto the top plane. If we project that line onto the front plane, we see this. And if we project it onto the right plane, we see that. So that's what they look like isometrically. Let's go back in and look at the top view when we're looking at the line projected to the top. And here we can see that it does line up perfectly with the 3D line that we projected. So in this case, if we're trying to look at this line from the top view, we want to project it from the top view. If we look at it from the front, that really does not provide any useful information. You can see a large discrepancy between the three-dimensional line we measured and what we're trying to use for our measurement in the software. And then looking from the right view, again, doesn't provide any useful information. Now, if we switch back over to a 3D line projected onto the front plane, we can see now this line is just projected onto the surface as you would see it from the front view. Again, looking from the top view does not provide any useful information here. Looking from the right view also does not provide any useful information. All right, the last line we'll look at is that 3D line projected onto the right view. So looking from the right view, we can see that that lines up perfectly with the original three-dimensional line. However, if we switch to the top view, we have no useful information here. And from the front view, we also have no useful information. All right, thank you for watching. I'll see you at the next video.